Hi, welcome to video number 6, I think, if I remember correctly. This video number 6. We kind of getting onto the home stretch, and we finally reached to the point of this CAPE Unit 2 Computer Science IA, where we get to actually do the code. So all the videos so far, videos 1 to 5, have just been videos about documentation, research, diagrams, all that kind of stuff. Because remember, as I said in all the other videos, Computer Science Unit 2 is not about Computer Science Unit 2 is not about just coding. It's about software engineering. So you are actually trying to make the software better. And to make the software better, I have to do a lot of research. But I say that in every video because you need to get it in your head that the code is not the most important thing here. But we actually reached the coding part now. I purposefully left out algorithm design and appropriate choice of data structures because we're going to change up the code so much that it wouldn't make sense trying to write over the algorithm with the search and all those different things, because we're going to add in some new functions, and when we add in new functions, we just update the algorithm after, because it's the same algorithm from Unit 1. So we'll reverse engineer the code into the algorithm after. Appropriate choice of data structures, that's more documentation, but I don't want to type up anything about data structures because I might go into the code and change some things and not be too sure exactly what it is. So I know the data structure so far, but we just had to basically type that up after the fact. What is the explanation? Notice these things are 3 marks: algorithm design and data structure. So pasting back the algorithm and making sure it doesn't look like C code is important. And justifying the use of the data structures. That's 3 marks. It's only about a paragraph you had to use, but that paragraph had to be like, very well written and shows that you understand. Right, so coding and testing requires us to go into the code, so it will be wise for us to jump straight into the functional requirements and see what do we actually have to accomplish here functionally. And once we know what we have to do functionally, then we could put those things in. So in the functional requirements, we need to add in the ability to delete a record, to search for a record by name, to request a stable report, request a ordered report, display patients in alphabetical order on reports. And then non-functional requirements make the user interface more intuitive, efficient searching using a better search algorithm, clear the report, have a clear report layout, user input validation, and sort the patients by ID in the database. So what I'm going to do is, instead of focusing on the functional requirements in this first video, I'm going to focus on the non-functional requirements, because these are the things where you have to put in your new functions, the new searches, the sorts and all that stuff. So essentially what I'm going to try to do is to put in a search and a sort and test to see if it's working, and maybe work on like the report layout or something like that. Because once we get these important non-functional things working, a lot of the functional requirements will be easy to do, because we'll be able to make the reports, we'll be able to put in alphabetical order, of course, as a sort. So yeah, so let's see if we could sort the information and search for it better. So we get to our code here. Need to zoom in for you to see the code. Do I have the input file for this? No, I don't have the input file. Hold on, I need to get the input file from the previous I take the unit 1i and take the input file data from there. Patients.txt. Yeah. Right, got you. Okay. Alright, I'm hoping that y'all will be able to read that properly, because that's as big as I'm going to make it. Alright, so we're going to go through the code now, and what we have to do is, there is a search function already here. But I don't want to use this search function because this search function is a linear search, and I consider a linear search to be less efficient than a binary search, of course, clearly. So you have to update the search patient function to do a binary search instead of a linear search. But before you could do a binary search, you have to make sure you sort the items. So before that, now we have to put in search. So we're going to start here. I'm going to put in bubble sort algorithm. Now I could do a selection sort, I could do a bubble sort, really doesn't matter. So I'll just name it void bubble sort. And I'm not too sure what's supposed to come in yet, but we'll get there. Right. Now you could go on type out all bubble sort, or you could go and find it in a book or something, or you could go on the internet and type bubble sort and see. And get the code. Get the bubble sort algorithm from anywhere. Do they have an example of it in C? Yep, C. Bubble sort. So I is gonna unjack this code here, and what we're going to do is put it in and then modify it. If you don't know how bubble sort works, well, you should know how bubble sort works. Now, in our case, we have a little issue because we're not dealing with an array. If I jack this code from the internet, so we're not dealing with an array, we're dealing with an array of structures. But the array of structures is already declared globally. So I'm not going to change how the program works. I mean, I thought I was going to, but if the array of structures is declared globally, then every function has access to it now. So I don't need to send the array of any array. I just need to send the size. So I'll just say int 10. Yeah. So n is going to be the number. So when I call this bubble sort, I'm going to have to send the size, which is going to be called actual size, because that's what we have in the code from before. Because we created a global variable called actual size that will hold the value of the actual size of everything in the array before we do it, right? So int I and j, good. So we have our integer I, we have integer j, we have our outside loop. The outside loop will start at 0 and go to n-1 because that's the size, going from 0. And then we're going to go from j to 0, j less than n-1 minus -1, because in a bubble sort you have to go to i-1. Now inside here is where we have to make our changes. We're not using our arrj, we are using p location j dot id, because we want to sort by IDs. So then we're going to be p location j plus 1 dot id. And then we have, well, we have to create a swap function also, because the swap function has to swap the values for us. So I'm going to jack the swap function here too. But of course I don't modify the swap function. So we're going to put the swap function right underneath here so we can have quick access to it. This may not work like the first time, because when you copy code from the internet, it doesn't always work, and you probably have to troubleshoot it a little bit. If you want, you can type it all the way over. That's cool, doesn't matter. So what I want to do is I want to swap the value of what is in p location j dot id. No, I'm not swapping one value, I'm swapping a whole structure. So in order to swap the whole structure, actually, I want to create a function for swap. I'll just swap the whole thing one time. So I'll write out the swap right here. So if one ID is greater than the other, I'll do the swap in place. Now you wouldn't lose any marks with doing the swap in place, because There are some bubble sorts where you just do the swap in place, and some bubble sorts where you call the swap. I am not going to call a separate swap function because I'm going to have to send the index to that function, and then the function has to swap one index with another index. And even though it makes it more functional, if you're okay with doing the swap inside the sort one time, go ahead and do it. If you want to create a separate function to do the swap, go ahead and do it either. I can't see you losing any marks with it because your functionality will still be there and you just chose to not write a swap function. There's nothing, anything that says you have to write a swap function because the code just has to achieve functionality. Even though some teachers will tell you should put the swap function because it's better coding practice, but there's so much other better coding practices that you could do. Like if you were to apply perfect coding practices to every single thing in the IA, your code will reach probably like 1,500 to 2,000 lines because there's always more that you could do. But do we achieve functionality? Yes. So let's swap. So if the patience location j.id is greater than patience location j.id, what? We're gonna swap. So we have to create a temporary structure. Temp struct patience. No, struct patience temp. Struct patience temp. Right. So we create a temporary patience structure. We say temp is equal to P location J and then we say P location J is equal to P location J minus 1, and then we say P location J minus 1 is equal to temp. That's a swap hand. Yeah. Right, now when you're swapping a structure, of course you can swap the whole structure. So all you have to do is just put P and location J, wherever index that is, that will swap it. And it's cool. And I'm creating the struct patience temp inside here because this will only run if the if statement. So you'll create this temp, it'll do the job, and then the temp will just kind of line and do whatever it has to do. Doesn't matter, this is just gonna be an empty structure. When it's done, it should print out the sorted values. So what I want to do is I have to declare this bubble sort I have to prototype it. So I'm going to buy the list of functions at the top, and I'm going to put that there as a bubble sort somewhere inside here before the switch. So I'll put that. All right, and it's a void function, so it'll just call the sort. So what I want to do in my main, first thing I want to do in the main is after I read all the information in the main, I read the password and whatnot, I read the data, I will call the bubble sort. Bubble sort. Now, shucks. Yeah. Now the bubble sort requires a size, so I'm going to send to the bubble sort actual size. Because actual size is the value that we're using. Let's see, I can't remember. Yeah, actual size here, because actual size getting updated. As soon as we read the data, we update in actual size to secret here. Right, so we send an actual size to this bubble sort in line 253, which is the main part. Bubble sort, actual size. Because actual size would have been updated as after we read the data. And then we sort it, and hopefully I should be able to display the information to the screen, which is one of the options. And no, I can't display any information to the screen. I don't have anything to display all the information to the screen. Alright, well, I'll just print it back out to the file and see what happened. Update patients, yeah, I'll call update patients. Yeah. Alright, so technically, if I run the program and then I leave it, it should update the file properly. So let me just open up this file here. I'm gonna create a file. Create file. Patients.txt. My goodness, did I have the names anyway? Yeah, I have it here. Right, so I have the numbers and I have the names. So technically, when I'm done, this patients.txt file should update to show the numbers in order. All right, so let's do what we normally have to do, check for errors. Do I get? Yep, of course I'm going to get errors. Line 166. 166. Struck patients temp. Oh, it should be struck patient temp. My bad. Line 166. Error. Struck patient temp. Does that fix it? Yep, does. All right. What's the password on this again? Yeah, swear I wasn't doing this like last week, or week before. 1111. All right. Okay, 1111. The data from the file is read properly, but then I have a problem. Segmentation fault code. All right, good. So that's a problem with a variable in the bubble sort. So let's see what's going on in the bubble sort. Figure out why. Int n actual size. Alright, so I'll copy out inside here. Swap structures in C, right? Swapping structures in C. Let me see what happened. No, they're swapping the value. Yeah, I think I was correct. Okay. Let's see. Alright, so for this swap, I don't know what's going on. So I'm just gonna put a printf. This is troubleshooting. I probably just like didn't pay attention to something. But as I normally do, I just kind of work through the errors and you'll kind of see these are the same errors that people normally have. You can fast forward through this if you want because I'm gonna fix it. The swap printf. The swap happens here. Right. Let me see if we'll say the swap happens here. 1111. Yeah, swap happens here. So okay, good. So something happening inside here that I can't make sense of. So I've struck patient temp. I created a temp patient. So let's go again and see if it will happen. If I get the error. 1111. All right. So the struck patient, the temp patient is being created properly. Let's see the next line. This is debugging 101. You check it piece by piece. All right, so I have that working properly. Then now, next line. Okay. And then next line. So the last line is the one that causing you problem. Why are you causing a problem? P location G minus 1 is equal to temp. But that's 100% correct. There's no issue there. Unless you're saying temp has nothing in it. Hold on 1 second. Let me check to see if temp actually has something in it. Printf. %d. temp.id. Run. temp.id \n. Yeah, we don't have to put in all this. You can just fast forward to me fixing this. 99 patient's file is 78 is the first number. Where you get 655, 122, and then you just get a lot of 78s. $990. Yeah, that's correct. So why we can't just take the value of temp, the stuff from temp and put it inside? P location J minus 1. You are working. Oh, yeah, doing shippiness. If every time you create a temp, that will happen here. You can't create a temp every single time the if runs. So we have to create this temp from on top here. Ew, right there, that makes sense. I'll leave these printfs here just to check. Alright, these are the mistakes that you would make too. So create a temp at the start. Let's see if it will accept my stupidity now. No, it still says problem. I have -1 here. So C+. Yeah. See what's up when you copy code from the internet? Yeah, now we'll accept it. Cool. So if I press exit, it should have sorted this. Hey, look at that. Alright, so my problem was I copied code from the internet and for some reason they had -1 instead of +1 inside the inside of the sort, but it's all good now. Alright, so in summary, what just happened is I created a swap the structures. Right. And the bubble sort is working. So how do I know the bubble sort is working? Let me show you this file, how it was before. So we're gonna show you that it was ordered like this, 78.99, blah, blah, blah. That was the case. This is clearly the IDs are not sorted. So when I run the program, look at the main. The main says, start off by reading the data. So that means I'll run through the file, read all the data, and then I'll pass it through a bubble sort and assign an actual size to the bubble sort. When you send it up to this bubble sort, what's going to happen is the bubble sort is going to bubble sort. I hate when you have to search through to find a function. Normally it's have this little thing on the side where you can see all the functions laid out, but when you prototype them, they got right. So the bubble sort is going to get the number n. N is actual size. We have to create an inner loop and an outer loop, which is I and j. If you don't know how to do a bubble sort, go download the app and you'll see I have videos about bubble sorting inside here. Then you have struct patient temp. We have the outer loop. The outer loop is going to jump through, and then we have the inner loop, which the inner loop is going to do the swaps. The swap is going to be swap_p location j.id with that one, and then it will do the swapping here. So my test based on my user interface will be, as soon as I run the code, it will say the data from the file has been read properly. Once the data from the file has been read properly, the next thing that will happen is the information has been sorted properly. So I'll put a printf that says printf the data has been sorted. Yeah, that'll be a nice touch to say, hey, the data has been sorted. Right. So now when I run the program, you can clearly see what happens. 1111, enter. The data has been read properly, the data has been sorted. How do I know the data has been sorted? If I exit the program, the update patients file will update the records in their current state. So if I exit the program, look at the patient's file now, ta-da, it's sorted by ID. Cool, so we've achieved one piece of functionality. Let's go to the next piece of functionality, which is the binary search. So after I have done this bubble sort, my next job now is to go and do the binary search. The binary search, however, is basically going to replace this linear search that I have here. The linear search is cool, but I want it to be a little cooler. So search patient receives a patient ID. In order for you to do that binary search, you have to know what's high and you have to know what's low, and you have to know like all the things that you need. So here I go again, copying code from the internet, binary search in C, and I will, Geeks for Geeks is always a good place because they just have the code in all different languages. So I'm going to take the binary search for C code, where is it? Here it is. Okay, cool. This is looking complicated. Oh no, that's the C++ one. Why are you asking me to sign up? Yeah. Why is there a, you're supposed to have the array? What's L? What's R? This binary search is looking a lot more complicated than the normal one. Let's not take this one. Somebody give me a normal binary search now. Like you need the first, the last, the middle. You need high, low, middle, and search value. Okay. Maybe I was looking at the correct thing. Oh, yeah, you need the array we're looking for, right? Good. Okay, it is correct. Why did they do this? Use high and low. You know, doesn't have to be this way. We could just use low and high, you know. Anybody have one at low and high? Alright, this one looks nicer. Yeah, I'll take this one. I'll unjack this one. Copy and code from the internet. Do it at your own risk, kids. Do it at your own risk. Alright, so I'm going to comment out this old search here, and we just go and paste in our binary search and make it work. So, int, we're going to replace the name of, it's still going to be the search patient function. Search patient. Okay, now remember, in my case, in this program, your program may not be done like this. Your program may have the structure declared inside of the main, and you have to keep sending the structure to different functions. Some teachers will require to do that. Some teachers will require to do it globally. When you do it globally, you don't have to keep bouncing the function around all over the place by sending it. So I'm just gonna take out the array here because we don't need that part. All we need is X, which is what we want to search for, and we need to get low and high. However, low and high will be 0 and actual size. So I will still leave low and high, so when I call the search, actually no. Low will be location 0 and high will be actual size. Yeah. So in my case, I am not going to receive low and high because my code already has just send the ID that I want to search for, and it will search. So what do? I just set low is equal to 0 and int low is equal to 0. And I'm gonna put int high is equal to actual size. Now, this will work in this code only. This binary search can't be taken and put in any other code because my code is just sending the ID to search for and giving you back the location, the index. That's all. You don't have to send low, you don't have to send high. Now, traditionally, a binary search will have to receive the array that you want to search, the value that you want to search for, the low and the high. If you're putting it like that, don't copy this binary search because this is tailored to my program. And more than likely, you're going to have to tailor the binary search to your program and your code. So please understand what the binary search is doing. So I'll just put a comment here and say, no need to send these values because they are global. All right? Actual size is global, so I just have to remember actual size just getting updated. Anytime we read from a file, anytime we add values, actual size updates. So I just had to use the same actual size all the time. Actually, I don't even need to use high, I could just use actual size, but for the sake of the binary search, we'll leave it like this, right? So we will leave a comment and be like, okay, check for high, yeah, right. So I'm not putting any comments inside the binary search. So while low is less than or equal to high, int mid, well, we could create the mid from, I don't like to declare variables inside the thing, so I'll just put int mid here. Int mid is equal to 0, right? Good. While it is on high, mid is equal to low plus high. High minus low divided by 2. Cool. Why do they have low plus high minus low divided by 2? I don't know. Right. So high minus low divided by 2 will give you what the mid is, right? If the array, what we're looking for, we're not looking for the array mid, we're looking for p location mid dot id is equal to x, which is what is sent. Return mid, that'll return the index. And if p location mid dot id is less than x, low is equal to mid plus 1, high is equal to mid minus 1, yeah, we update that, and if it do ever return anything, that means nothing happened, or else it return -1. Okay. All right, so let's see if we can search for our patient. 1111. Search for a patient. We will put patient. Now the information sorted there. So good. So I'm going to be able to search for a patient and put patient. Enter the patient ID I'd like to search for. I am going to search for patient 122. That should tell me it's at index 5, I think. So I want to search for 122. And the binary search is not working. So let's stop. Search patient. Okay. Now we have to figure out what's the problem. (122) is a patient, and yeah, that's what we're going to see. Alright, so while low is less than or equal to high, mid is equal to high minus low divided by 2. That's normal. If P location mid.id is equal to X, X is an integer. Yes, the ID is an integer. Return mid. This search function asks them I want to search for, send a search, and then it'll print info. It should just go back the index here. Alright, let's see why. Right, return mid. If p mid is equal to x, right? If p mid.id is less than x, low is equal to mid plus 1, high is equal. Alright, this could be the actual size problem because the actual size, no, I fixed our actual size this year already. Actual size would be number. Okay, let me just do a printf and make sure I get the correct size. Printf, the actual size. Value is %d, comma, actual size. Search for a patient 122. It's in the actual size is 12 and stopping. What is the actual size? It is 12. So it'll be 0 to 12. Yeah, that's correct. Is low plus high divided by 2. That was really stupid. Yeah, the code that I copied had low plus high minus low, some kind of thing. So anyhow, yeah, high plus low divided by 2 should be binary search. That was my essay there. This should fix it, I hope. 3 search for patient 122. Yep, I got the value. The patient was found at location 4. Based on this code, 122 should be 120, 1234. Right, good. So we did find William Murphy. Binary search works. Yet again, another example of copying code from the internet. You will hurt yourself. And if you don't understand what you're doing, copying the code from the internet, you'll spend hours trying to debug the ISU. So it might be wise for you to go to your notes and type over the code. Make sure you understand how the binary search is working. Or more than likely, you might have to go to your teacher and be like, this is not working, and the teacher will find it for you. One of the two. The problem is if you don't have a teacher, you'll have an issue. So I could take off this actual size here. So the binary search is working, and now I could search for a patient and and say that the patient does exist, right? Now, that achieves two of my new functional requirements. My non-functional requirements would be search for the patients by ID in the sort the patients by ID in the database, and efficient searching using a better search algorithm. So I could search via ID. Now I did have in the functional requirements a search for record by name, which I can do. So let's see if I could how much time I have? Alright, so let's see if I could get the search to show the patient by name. If I put search patient ID, search patient name. Yeah, already bit off enough that, yeah, that's enough there so far. Next video I'll do the search patient by name, because that'll require me to put in a whole new search, which I will more than likely have to change over the main and take out the option of just searching for just to search for a random patient. I'll probably have to fold in the function of searching for the patient and printing the patient record to the screen into one function, and then allow the person to search for an ID or a name and call the appropriate search at that point in time and display the patient information to the screen. Yeah, alright, so let me just try it and see if I print a patient record to the screen if everything will work, because technically all I did was swap out the search, so the index finding is still going to be the same as the linear search, so the other functions should not be affected, because that's what makes functionality work. So if I want to print a record to the screen, choice 4, enter the ID I'd like to print, 122, it should print William Murphy to the screen. Perfect. Because the binary search was just swapped out. But in order for the binary search to work, I had to put the selection, the bubble sort in. So we got the bubble sort to work, then we got the binary search to work, and now the program will continue running flawlessly because we just made the search more efficient and we put the sorted in. That's the good thing about functional programming. So that's one of the things I want to try to do when you do software engineering. Swap in a function, change it, it's still gonna have the same inputs, give you the same output, but the processor is going to do it really different. So the patient ID will be displayed to the screen. So what I will do in the next video is that we will go and we will start to deal with some of the more front-facing things now, which will be like the type of IDs that you see, the names that you see and whatnot. So we kind of knock off on the functional requirements, the hard stuff, which is efficient searching using a better algorithm, sorting the patients in the database, good. Everything else is user interface, report layout, input validation, report, searching for record by name, and then we have the delete record. So all those things we could do in the next video, because those are front-facing things, and that's just a lot of yeah. And then display the patients in alphabetical order on the reports. That's a different kind of sort. We'll have to do a bubble sort by name. That'll be all technical. But when we reach to the report part, we'll do that. So the next video, I'll probably deal with all the user interface, front-facing stuff. And then the other video will deal with the reports and what we have to change. But it's really not that much. We just got the binary search and sort to work. So that's it for this video. Of course, all of this is going to be put back into the algorithm after when we finish. But at this stage, what you want to do is you're trying to make sure that your code achieves functionality. All the things I'm supposed to do, error trapping. And there's only 5 marks I'm working for here, but this is going to take aside from the diagrams, this is the longest amount of time because you're going to spend time coding, but it's only 5 marks you're fighting for. But actually you're fighting for 10 marks because you have to change the design also, the design specifications to make sure it matches to it. So you're fighting for that 10 marks, whereas you fought for all the 10 marks. But it's cake. Nothing comes easy. So I will see you in the next video. Next video, we will try to knock off some more of these functional requirements and get some of the user interface things sorted out and give them the ability to do some of the things that they didn't want to do. So there's some back-end stuff, but there's also some front-end stuff, but we did most of the hard back-end stuff just now. So I'll see you in the next video where we go back into some more code, okay?